Hi folks, today we're going to talk about solving polynomial equations. For the last few days you've been reviewing how to factor polynomials, and that's going to come in handy today. Now we've got a little chart at the top of our notes that gives us kind of a quick look at several factoring techniques. You always want to check to see if you can factor out a GCF. If you have a trinomial, then you can factor using the magic numbers. So I might write this here, magic numbers. If you have a perfect square trinomial, meaning you can recognize that the first and last terms are perfect squares, and the middle term is the square root of the first term times the square root of the second term, but doubled, so multiplied by 2, then you can factor this. Sometimes this one is a little difficult to see, but with practice it gets a little easier. The difference of squares, meaning the difference of two terms that are perfect squares, you can split these into a times a and b times b. So basically you can square root your first and second terms. And whatever you get when you square root, you can put them together in each factor and give one a plus sign and one a minus sign to connect them. That's the difference of squares. You can factor by grouping if you have a 4-term polynomial. And then sum or difference of cubes, which is the only one that doesn't have a square. It's one that has a cube. So if you notice that you have a binomial with two perfect cubes, either being added or subtracted, then you have a sum or difference of cubes problem. Basically, you can cube root, and whatever you get, you can put it together here, and then a times a times b times b. And the signs can be remembered by SOAP. So if the sign is a negative originally, then you have the same sign, the opposite sign, and then always plus for the last sign. If the sign that holds them together is a plus sign, then you have the same sign, the opposite sign, and always a plus sign. So that helps you remember the sum or difference of cubes. Now it is also important to remember that when you're doing the difference of squares, you can factor the difference of squares, but you cannot factor the sum of squares. That is not something that you can factor. So here, I could square root x squared and get x. I could square root 4 and get 2. And so this would be x plus 2 and x minus 2. And I could check that by using FOIL. So x times x is x squared. X times negative 2 is negative 2x. 2 times x is 2x. And 2 times negative 2 is negative 4. My middle terms, negative 2x plus 2x, cancel out, and I have x squared minus 4, just like my original problem. So this is right. However, I cannot factor the sum of squares. There is nothing that whenever I FOIL it back together will give me the middle terms that cancel out and a plus 4. It just won't happen. So we say that this is prime, that it cannot be factored, and so it is prime. So just remember that whenever you're looking at difference of squares, if you have a sum of two squares that can't be factored, that is prime. So this is just a little review of the factoring that you've done over the last couple days, but really a couple months. So I'm going to go on to the second page. Now the second page starts out with a question that is going to begin kind of the next 3 or 4 sets of notes, which is all about trying to solve equations that have strange things in them. Either they have larger exponents, or they have cube roots, or they have exponents that are a little strange, so maybe the exponents are like fractions or things like that. So the next several sets of notes are all going to be about how to solve equations with these strange exponents or cube roots or things like that. So we're going to start out today by factoring the following sum or difference of cubes. You can go to the factoring booklet. We're just talking about the factoring table on the first page of these notes. So if you need to, go to the factoring table to review. But let's look at this problem. Is it a sum of cubes or a difference of cubes? Well, it would be a sum. because there's a plus sign right there. Now let's go ahead and calculate the cube root of 27x cubed. Well, what's the cube root of 27? What times itself 3 times will give me 27? That would be 3. 3 times 3 is 9, times another 3 is 27. And then the cube root of x cubed kind of wipes out the root and the exponent, and you're just left with x. What about the cube root of 8? What times itself 3 times will give you 8? The answer is 2. So when you put together your sum of cubes, you want to put together a plus b, and then a times a times b, b times b. Remembering that your signs can always be found by using SOAP. So if the sign connecting the original 2 terms is positive, then you would have the same sign, the opposite sign, and then always a plus sign for the third one. So let's put together our answer, our sum of cubes. So this is a, this is b. It's what you get when you cube root your first term and your second term. So a is 3x. I'm going to put that here. The same sign is a plus sign. My b is 2. Close my parentheses. A times a squared. That would be 3x times 3x. Well, 3x squared, 3x times 3x, 3 times 3 is 9, and x times x is x squared. So this would be 9x squared. Minus opposite signs, a times b. Well, 3x times 2 would be 3 times 2, which is 6x. And then always a plus sign, b squared would be 2 squared, and 2 squared is 4. So we got it. We have SOAP that's helped us find the sum of cubes after we cube rooted the first and the second term. So now we've already done part A of number 1. Part B says that we need to solve the following cubic equation using the problem from above. Now, what we're going to do today is based on something called the zero product property, and I'm going to do it out here over to the side. Zero product property means exactly what it sounds like. It means that you have multiple things that you're finding the product of, that you're multiplying, but one of them is 0. So if I have any number, say 50, and I multiply times 0, well, the product of 50 and 0 is always going to be what? 0, right? Because you're multiplying things together and one of the numbers is 0. If you have 0 times any number, anything, then you're always going to get 0. And same thing if you multiply 0 times 0. Well, of course, you're going to get nothing. So the zero product property says that if you multiply 0 times anything, you will always get a product of 0. Now, that's really helpful to us because what that means is that I'm going to use this factoring of my polynomial, because what happens is I take my factors and what am I doing with them? They're touching, which means they are being multiplied, and I'm finding the product of them. So that's great. That means that instead of 27x cubed plus 8 equals 0, I'm going to say that what 27x cubed plus 8 factors to be, an equivalent expression, I'm going to say that that equals 0. So 3x plus 2 times 9x squared minus 6x plus 4. That equals 0. Now remember that this factored expression is exactly the same as this original expression. It looks a little different, but it has the same value. It's an equivalent expression. These two mean the same thing. So, in order to solve, I want to invoke the zero product property. Either this needs to be 0 or this needs to be 0 in order for the product to equal 0. So we're going to separate these two, and we're going to do it in two different chunks. So the first thing we need to check is, what does x have to be over here so that 3x plus 2 is 0? Well, if I solve this equation and I subtract 2 from both sides, 3x equals negative 2. And if I divide by 3, I get x equals negative 2/3. So there's one x value. And giving x the value of negative 2/3, if I substitute it here, here, and here, it doesn't matter what this is, because this term will be 0. So let's try to find an answer with this one. So this looks a little daunting. I could try and factor this. I don't think that that's going to work, and so I'm going to try using something, especially in our first example, that will always work, and that's the quadratic formula. So I have x equals, if your teacher sang the song to you, then I'm going to sing it now. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So there's the quadratic formula that happens to be on the internet. It happens to be on your formula charts. If you were to get formula charts when you test, it would be something given to you on the STAR test if you had a STAR test for this subject. So it's always there for you. So let's go ahead and label your A, your B, your C. X equals negative b, which is negative 6, plus or minus the square root of b squared, so negative 6 squared, minus 4 times a times c, all over 2 times a. And you have calculators that you could put this discriminant in, if you remember that. Negative 6 is really positive 6. If I typed this into a calculator, I would end up with negative 108 all over 2 times 9, which is 18. So next thing I would do is I would try to kind of I would try and break this down, simplify this radical. Now I'm not sure if you remember this, but I'm going to get a different color. Hopefully you can see this color. This right here, I can see automatically that it has a negative in front of it. So that means that I'm going to be pulling out the square root of negative 1 and separating it from 108. Because do you remember what the square root of 1 is? The square root of 1 is I. It's I. It's an imaginary component to a complex number. So now I need to break up the square root of 108 into some things. So maybe I can break this up into, maybe I can break it up into 36 and 3. So now I have 6 plus or minus. The square root of 36 is 6, and there's an I with it, so 6i square roots of 3 over 18. And now I see that I have a term and a term and a term that all are divisible by 6. So I'm going to divide these two by 6, and I'm also going to divide these two by 6. So this and this. So 6 divided by 6 is 1, and 1i square root of 3, and 18 divided by 6 is 3. So here I have an x value here, and I have an x value here, but really I have 1 plus I square roots of 3 over 3 and 1 minus I square roots of 3 over 3. So all in all, I have 3 solutions. There was only one real solution, And there were two imaginary solutions, one with a plus and one with a minus. Now this imaginary solution means with I. So how many answers did you have with I? Well, we had two of them, one with a plus and one with a minus. So the solutions are negative 2/3. And then you can write these two together just as they appear, 1 plus or minus I squareds of 3 over 3. Now order really doesn't matter here very much because these i's make these complex numbers and they don't fit on a linear number line. So either order, either of these first would be fine. So you're not always going to have complex answers, but occasionally you will. So it's nice to have examples of what those look like. So let's look at number 2. Number 2 says solve x to the power of 4 minus 10x squared plus 9 equals 0. Well, wouldn't it be nice if I could use my zero product property? And of course I can. If I can write this polynomial as its factored form, then I can get things that multiply by each other to get 0. So let's go ahead and try and factor this. It's a trinomial, so I might try and use magic numbers. So two numbers that multiply to give me 1 times 9, which is 9, and add to give me negative 10. Think about numbers that do that. 9 times 1 is 9, and 9 plus 1 is 10, but I need them to be negative. And if I make these negative and multiply, I'm going to get a positive product, so that's good. So let me go ahead and write my factors that still equal 0. Now, of course, this isn't going to just be an x. It's going to be the square root of x to the power of 4. So I'm going to kind of divide this by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. So I'm going to use x squared here and x squared here, along with my magic numbers of minus 9 and minus 1. Well, I notice that these two are binomials, and they're differences, and they're both differences of perfect squares. X squared is a perfect square, 9 is a perfect square, 1 is a perfect square. These are perfect squares. So I'm going to go ahead and split this into my difference of squares. Oops, I wanted to use a different color here. There we go. Okay. So if I square root x squared, I get x. If I square root 9, I get 3. And in order for the middle term to cancel out and not be a trinomial, I need a plus 3 and a minus 3. Here, if I square root x squared, I get x. If I square root 1, I get 1. And in order for the middle term to cancel out and not be a trinomial, I need a plus 1 and a minus 1. Okay, so I have 4 sets of parentheses. That means that I could have 4 possible factors that could be 0 and still give me a product of 0. So I'm going to set each of these equal to 0. Either x plus 3 could be 0, x minus 3 could be 0, x plus 1 could be 0, x minus 1 could be 0. All of those possibilities would make a product of 0, so we have to include them all as solutions. So these are all little one-step equations. Either x is equal to negative 3, or positive 3, or negative 1, or positive 1. So these are my solutions. My solutions are negative 3, negative 1, 1, and 3. How many solutions are there? There are 4. How many real solutions? All of them are real, so all 4. Are there any imaginary solutions with I? No, there aren't. So kind of the easier way to do these problems, or at least the way to do problems that don't end up having imaginary numbers, is to take your problem, factor it, and set each of the factors equal to 0. That way you can solve for x. So let's move this page and go to page 3. We've got 2 more examples to go. All right. So factor by grouping, factor completely, and go to the factoring table on the front page if you need a review. Notice that A and B are the same problem, except here we have our polynomial equals 0 and we are expected to solve. So we're going to take this problem and factor it first, and then we're going to solve. So let's factor. It's a 4-term polynomial, so I should probably factor by grouping. Are there any GCFs first? 2 and -4 and 16 and -32, those are all divisible by 2. So let's go ahead and divide them all by 2 first. And that way we can take out our GCF and we have a more simpler problem to work with. More simplified, not more simpler. Here we go. Okay. So I've got still a 4-term polynomial. So I'm going to break it up into 2 groups. One group will be x to the power of 4 minus 2x cubed, and the other group will be 8x minus 16. Notice that I have parentheses around the whole problem and a 2 out for the GCF. I might change those exterior parentheses to brackets just to kind of keep my head straight. The GCF of these 2 would be x cubed. So x cubed comes out, and x minus 2 stays in. The GCF of 8x minus 16 would be 8. So a plus 8 comes out, and an x minus 2 stays in. And so we end up with 2 times x minus 2 times x cubed plus 8. Well, wait a second. I notice that this is a sum of 2 cubes. The cube root of x cubed is x, and the cube root of 8 is 2. So I can break this up even more. The GCF and the x minus 2 stay. However, if I use SOAP, the cube root of x cubed is x. The cube root of 8 is 2. The sign is a plus sign. The opposite sign would be a minus, and then always plus at the end. A times A would be x times x. That's x squared. A times B would be 2 times x. That's 2x. And B times B, that would be 2 squared. That's 4. Okay. So I have a lot of terms here. And if I'm asked to solve this polynomial equation, well then I'm going to rewrite the polynomial on the left as its factored form. So 2 times x minus 2 times x plus 2 times x squared minus 2x plus 4 equals 0. So we have all of these factors, and only one of them has to be equal to 0 in order for this to work. So either 2 is 0, which makes no sense, or this is 0, or this is 0, or this is 0. We need to come up with all of those different possibilities. So first let's look at the GCF. Could 2 be equal to 0? No, that doesn't make sense. So no solution is gained from setting 2 equal to 0, but you should always check the GCF. Here, what about x minus 2 equals 0? X would have to be 2 in order for this to happen. So 2 minus 2 is 0, and it doesn't matter what these are, because if you multiply by 0, then your equation is true. What about here? X plus 2 equals 0, so x would equal -2. And then here, this is a trinomial that we haven't factored, so let's go ahead and use the quadratic formula. X equals -b, which is -2, plus or minus the square root of b squared, so -2 squared, minus 4 times a, which is 1, times c, which is 4, all over 2 times a, which is 1. Okay. Negative negative 2 is just 2. We have the square root of, if you type in all of this into the calculator, you would end up with negative 12. Oh, negative under the radical implies we're going to have an imaginary answer. 2 times 1 is 2. Let's go ahead and simplify this radical. Break it up. The square root of negative 1 and the square root of 12 would be I times the square root of 12. Well, the square root of 12 can be broken up into the square root of 4 and the square root of 3, because 4 times 3 is 12. So when I put all of this together, I end up with 2 plus or minus. The square root of 4 is 2 with an I and a square root of 3, all over 2. And I notice that the 2 and the 2 and the 2 can all be simplified by 2. So all the 2's get divided by 2 and they become 1's. So this is really 1 plus or minus I square roots of 3. So we have all of these answers. Now the number of solutions, 1, 2, 3, 4, right? We have one that's 1 plus I squared roots of 3 and one that's 1 minus I squared roots of 3. So there are 4 solutions. How many real solutions? Those 2. How many imaginary solutions? Those 2, because they have i's. What are the solutions? Well, it doesn't matter what order we list them in, but I'll list them as maybe plus or minus 2, because a positive 2 and a negative 2 are both our solutions. And then 1 plus or minus I squared roots of 3. So it's kind of a consolidated way of writing it. You're welcome to list out these as separate, positive 2 and negative 2, and that's okay. But you could also write it like this. Now the last question that we have today is a little different. It says, write the polynomial equation. Not solve it, but write it. For the equation that has the following roots. Remember that a root is a solution. So basically it's asking us to go backwards. It's saying, I'm going to give you these 2 solutions. You need to figure out what the equation is, instead of, given the equation, find the solutions. So our process has been to factor, and then to set each factor equal to 0 and solve. Well, now we need to go backwards. We need to set each of our solutions equal to x, and we need to move it over so that it equals 0, and those will be our factors. So each of these, x equals 2, x equals 3i, and x equals negative 3i, are our solutions. I'm going to move this over so that I have 0 over here instead of 2. So I'm going to subtract 2. I have x minus 2 equals 0. Do you see that? So my factor is x minus 2. Same thing here. I'm going to subtract 3i. I'm going to have x minus 3i equals 0. So x minus 3i is a factor. Whoops, x minus 3i. Same thing here. I have minus 3i, so I'm going to add 3i so that I can move it to the other side. I have x plus 3i equals 0. That means x plus 3i is a factor. So all 3 of these together are my factors. So I'm going to take them and I'm going to multiply them and set them equal to 0. So I have x minus 2 times x minus 3i times x plus 3i equals 0. Let's multiply these together. I'm going to leave x minus 2 over here for a second, but I'm going to multiply these together with FOIL. So x times x is x squared. X times 3i is 3ix. Negative 3i times x is negative 3ix. And negative 3i times 3i is going to be negative. 3 times 3 is 9. I times I is I squared. And think about this. What happens to the middle terms? They cancel out. What happens to this term? What is I squared? Remember, I squared is negative 1. So when I rewrite this factor, this is x squared from here, and then negative 9 times negative 1 is plus 9. So this is looking way better. And now the last thing I need to do is to FOIL these so that I can get my true equation in a polynomial form. So x times x cubed, or sorry, x times x squared is x cubed. X times 9 is 9x. Negative 2 times x squared is negative 2x squared. And negative 2 times 9 is negative 18, and that is equal to 0. Now the last thing that I might do is reorder this so that it's in descending exponent order. So this is my biggest exponent. This is my next biggest exponent. This is my next biggest exponent. And then this is my constant. And this is the polynomial equation that would give us the solutions of 2, 3i, and negative 3i. You just have to work backwards. You set your solutions equal to x. You move them over so that you have equations that are equal to 0. Whatever equals 0 becomes your factors. And then you take those factors and you multiply them together with FOIL. And that's it. So today we were able to use our factoring knowledge and recall our knowledge of complex numbers to solve equations from polynomial form.